Good morning, student. We were studying chapter number 6, system of particle and rotational motion. Let's continue this chapter. Okay, so I told you about center of mass for a particle system, two particle system, three particles, and particle system. Now for a body, for a rigid body, what will be the center of mass? Okay, for that we can treat the body to be a continuous distribution of mass. Okay, so in the continuous distribution of mass, there is almost the particles are very close, there is no gap. Okay, actually it is written in this line, you can see the number of particles in such a body is so large that it's impossible to carry out the summation over individual particle. We cannot sum all the particles, so we treat this as a continuous distribution of mass. Okay, in that what we can do, we can divide the entire body into small element of mass. Okay, so the element of mass will be delta m1, delta m2, delta mn. Okay, up to delta mn. Okay, so we will do the similar thing that we do for the one particle, two particle, three particle. Okay, that this was the formula we had arrived. If you recall, we had arrived the formula here. Okay, so what was the x coordinate of the center of mass? Summation of mi xi, where mi is the mass of the ith particle, and xi is the, this is the position of the ith particle, x coordinate of the ith particle. Okay, so similarly here what will arrive will be the summation of the delta that we have assumed, this small mass we have divided, we assume mass to be, the whole body to be made of small mass element. Okay, and this is your delta mi xi upon delta, the summation of delta mi. Similarly for y and z coordinate we will obtain the similar term. Okay, and if you remember, this is similar to what we do in integration. Okay, we just take, like if you remember, I'll just draw it. Okay, just a second. Yes, if you remember, we have this for force versus displacement graph. Okay, what does the force versus displacement graph gives? Work done gives area under force versus displacement graph gives a work done. Okay, but if the force is not continuous, okay, not constant, the graph is something like a curve. So what we do, we divide this whole area in small rectangle. What the benefit of this? Okay, so for this small region, force is almost constant. Okay, and if we just keep on dividing this rectangle to very small rectangles, so such that this is delta x. Okay, if this becomes very small, infinitesimal, so this tends to be 0, and when this tends to be 0, then for that very small change in position, okay, then we can assume the force to be constant. This was the basic idea of integration. And when we are able to make it into, and when we sum this all these strips, okay, very small strip, infinitesimally small strip, then what we do, we got work done, and this is the integration of f dx. We have divided the whole area into very small strip dx. Okay, and when we sum, okay, take the that is called the integration. Okay, the summation change to integration when we take the delta x tend to 0 limit. Okay, similar idea we are executing here. Okay, and now, yes, so this summation of delta m changes to summation integration dm. Okay, and which is what the denominator is, what if you all add up all the small mass element, we got the mass of the whole body. Similarly for the above part, the summation change to integration. Okay, so now this is how we will obtain the center of mass, coordinate of the center mass for a solid body, rigid body. Okay, for a continuous distribution of mass basically. Okay, and if we choose the center of mass as origin, the r will be 0, the position vector of the center mass will be 0, and it will be very easy to solve. We always choose the center of mass as the origin. The calculation very simple. We will do all the calculation, our discussion in terms of center of mass as the origin, and it will make our discussion, our understanding very easy. You will see later in the chapter. Okay, and so we can, with the help, we can determine the center of mass of different bodies. Like this rod, we can determine the center of mass. Again, what we do, we take a small element. Okay, very small element, this is the dm, small mass element, Okay, and then we integrate it for the whole rod, and we will obtain the center of mass, and it will, by using the symmetry we can see. Okay, this, because this is a uniform mass ruler. Okay, the mass is shown constant throughout the this meter scale. So the mass on the left side, okay, of this center point, and the mass on the right side of the center point are equal. So center of mass for this, by just by symmetry, not even using the mathematics, it's come out to be the center. Okay, the center will be the center of mass in this case. Okay, that's the benefit we will get in the symmetrical object. Okay, so there are some questions that you can try. We will discuss this in class too, based on center of mass. Okay, now motion of center of mass, this is given. It is all mathematics, but I will give you the basic idea. The mathematics is rigorous here, but the basic idea is, okay, what you see, that the body is made of a large number of particles. The body is made of a large number of particles. Okay, and they are exerting force on each other. Okay, they are exerting force on each other, but the net force is zero. Okay, sum of all the internal forces is zero. So if we exert external force on the body, then the total force will be what? External force plus the sum of all the internal forces, and I told you that those internal forces sum up to zero. So what we get? Only the external force. Okay, so this will be the external force will be equal to what? Mass of the whole body, and a, and what will be the a? Acceleration of the center of mass. So all this sum up to this. Okay, all this mathematics is there. Okay, not very important for the exam, but for your understanding you should know the derivation. They are just telling us that we can consider the whole body, or we can consider the center of mass. Exerting force on the whole body, the whole body will move with the acceleration, and the center of mass, if the same force is applied to the center of mass, considering there is a mass at the whole mass, point mass at the center of mass, and the force is applied, then the acceleration of the center of mass will be the acceleration of the whole body. So what we can do, as I told you in the beginning of the chapter in the previous lecture, that the whole body moves, the center of mass, we can consider the whole body, whole body mass to be considered the center of mass, and this force will move the body with the a acceleration, which is similar to the body. So this will be very easy to understand. We can consider whole body as a point mass. Just read this paragraph, this line that is written in the bold. This is very important, and I want you to understand it. Read it again and again. Okay, so it says, the center of mass of a system of particles moves as if all the mass of the system was concentrated at the center of mass, and all the external forces were applied at point. Very important, it has to be read again. This is the main crux of whole the center of mass idea, that, as I told you, we can okay, the center of mass moves just like the whole mass of the system of the body is concentrated at the center of the mass, at the center of mass. Okay, and the all the center external forces are applied at that point. Okay, whole derivation idea is this. Okay, it need to be the mathematics, you have to go through mathematics, that equation we will do in class. Okay, so basic idea is this. Okay, and now next thing is, okay, and for understanding this is a very beautiful example to understand what I told you. Okay, so if you see, there is a projectile, it is so suppose this is a bomb. Okay, and this projectile, it is moving in a parabolic path. Okay, very easy to understand. Now in the moving through the parabolic path, an explosion occurred in the this bomb, we can say, and it breaks into fragments. Okay, so the obviously the fragment will move in different direction, but very interesting thing to know is that the center of mass will keep on moving along the same path that it was moving before the collision. Okay, so this is what we have seen, that we can assume the whole body, the whole body is now fragments that are moving in different direction, but we can assume the whole body to be at the center of mass, which is moving on the same line as like that there is nothing has happened to the whole body and is moving along the same path. The acceleration is whole force is acting on the center of mass, it is moving along this. Okay, so because there is, in this case there was no external force, actually the explosion occurred on its own, so the centermost of mass will not be affected, there will be no acceleration, it will keep on moving along the same path. So this justified that. Okay, so this part, okay, if this needs a lot of understanding, lot of rereading, and then you will able to understand this. Okay, so give it little more time. It's not just you will just read one time and you will understand this concept. Why we are using this has to be understood again and again. Okay, and then there's this okay, this is what I called you momentum. You know, momentum is mass into velocity, force is the second law, dp by dt, rate of change of momentum. If there is no external force, the momentum will be constant. Momentum of the center of mass will be constant, it will keep on the same path, as I told you, if there no external force is applied. Okay, and there is again one example, more example is there. Radon collides, splits into two, helium and xenon, and it will, the center of mass will keep moving along the same path. Similar for binary star is there. There are two binary stars, but the center of mass, this, because there is no external force, it will keep moving along the same line. Well, this is all the crux of this. Okay, vector product of two, actually I told you about already about a vector product. The two vectors are multiplied. Okay, what we'll get, we'll just get a vector. Okay, and what is the vector product? A cross b is equal to a magnitude b magnitude sine theta, and n cap, that is the unit vector on perpendicular to the plane containing the two vectors. And there are certain rules related to this, like it is not commutative. Okay, the scalar product was commutative, but this is not commutative, this is a minus sign. Okay, so what we'll get if we just take the change the order of the cross product, the direction will be changed, the cross product direction will be changed. Okay, opposite direction to the what we'll get. Okay, a cross a vector cross with itself will give you a null vector. Okay, and if we vector cross I cap cross I cap is 0, I told you. Okay, and there is a method to do this, which will I'll show you in the class how to do the cross product. Actually I have already told in the vector chapter. Okay, now the second part is there, I'll make the separate video for the next part of this chapter. I hope you understand this. Give it a time. This was the center of mass, and the importance of this was a little rigorous, mathematical rigorous. You need to carefully do it again and again, and ask me if you are in doubt in the class. Thank you for now.